Docker Introduction. Docker is a tool designed to make it easier to create, deploy, and run applications by using containers. Containers allow a developer to package up an application with all of the parts it needs, such as libraries and other dependencies, and ship it all out as one package. An open-source project that automates the deployment of software applications inside containers by providing an additional layer of abstraction and automation of OS-level virtualization on Linux. In a normal virtualized environment, one or more virtual machines run on top of a physical machine using a hypervisor like Xen Hyper-V, and ESXi, etc. Containers, on the other hand, run in user space on top of operating system's kernel. It can be called as OS-level virtualization. Each container will have its isolated user space, and you can run multiple containers on a host, each having its own user space. It means you can run different Linux systems. Containers on a single host. For example, you can run an RHEL and ASUSE container on an Ubuntu server. The server can be a virtual machine or a physical host. In this image, we can see in traditional deployment we have one hardware and O/S, and on that O/S, we deploy different applications, due to which the applications run slow and even are crashed due to memory issue. As we move further in virtualization deployment, we came to use virtual machines like VMware, VirtualBox, etc. Here in an O/S we installed different hypervisors, VMware, VirtualBox, Hyper-V, and in those hypervisor we install different O/S and run the applications. This is quite good as compared to the traditional method, but the same problem is here related to memory, as here we allocate the memory to the hypervisor is bounded and cannot be used anywhere. To tackle this, here we introduce Docker. It works on containers and is much faster than other deployment methods. The underlying technology namespaces. Docker uses a technology called namespaces to provide the isolated workspace called the container. When you run a container, Docker creates a set of namespaces for that container. These namespaces provide a layer of isolation. Each aspect of a container runs in a separate namespace and its access is limited to that namespace. Docker is developed using the Go programming language. Go is an open-source programming language that makes it easy to build simple, reliable, and efficient software. Docker Engine uses namespaces such as the following on Linux. The PID namespace, Process Isolation, PID, Process ID. The Net namespace, Managing Network Interfaces, Net, Networking. The IPC namespace, Managing Access to IPC Resources, IPC, Inter-process communication. The MNT namespace, managing file system mount points, MNT, mount. The UTS namespace, isolating kernel and version identifiers. UTS, Unix time-sharing system. Control groups. Docker Engine on Linux also relies on another technology called control groups. A group limits an application to a specific set of resources. Control groups allow Docker Engine to share available hardware resources to containers and optionally enforce limits and constraints. For example, you can limit the memory available to a specific container. Union file systems. Union file systems, or UnionFS, are file systems that operate by creating layers, making them very lightweight and fast. Docker Engine uses UnionFS to provide the building blocks for containers. Docker Engine can use multiple UnionFS variants, including AUFS, BTRFS, VFS, and Device Mapper. Container format. Docker Engine combines the namespaces, control groups, and UnionFS into a wrapper called a container format. The default container format is libcontainer. In the future, Docker may support other container formats by integrating with technologies such as BSD jails or Solaris zones. Principle of Docker. Docker works on the principle of build, ship and run any app, anywhere. Docker really does let you build your apps and then run them anywhere. It does not matter what tech stack you use, or where you run it. As long as you have Docker installed and know how to use it, then you are good to go. Flexible, even the most complex applications can be containerized. Lightweight, containers leverage and share the host kernel. Interchangeable, you can deploy updates and upgrades on the fly. Portable, you can build locally, deploy to the cloud, and run anywhere. Scalable, you can increase and automatically distribute container replicas. What can I use Docker for? Fast, consistent delivery of your applications. Docker streamlines the development lifecycle by allowing developers to work in standardized environments using local containers, which provide your applications and services. Containers are great for continuous integration and continuous delivery, CI/CD, workflows. Consider the following example scenario. Your developers write code locally and share their work with their colleagues using Docker containers. They use Docker to push their applications into a test environment and execute automated and manual tests. When developers find bugs, they can fix them in the development environment and redeploy them to the test environment for testing and validation. When testing is complete, getting the fix to the customer is as simple as pushing the updated image to the production environment. Responsive deployment and scaling. Docker's container-based platform allows for highly portable workloads. Docker containers can run on a developer's local laptop, on physical or virtual machines in a data center, on cloud providers, or in a mixture of environments. Docker's portability and lightweight nature also make it easy to dynamically manage workloads, scaling up or tearing down applications and services as business needs dictate, in near real time. Running more workloads on the same hardware. Docker is lightweight and fast. It provides a viable, cost-effective alternative to hypervisor-based virtual machines, so you can use more of your compute capacity to achieve your business goals. Docker is perfect for high-density environments and for small and medium deployments where you need to do more with fewer resources. Docker Engine. Docker Engine is a client-server application with these major components. A server, which is a type of long-running program, called a daemon process. The Dockered command. A REST API, which specifies interfaces that programs can use to talk to the daemon and instruct it what to do. A command line interface, CLI, client, the Docker command. The CLI uses the Docker REST API to control or interact with the Docker daemon through scripting or direct CLI commands. Many other Docker applications use the underlying API and CLI. The daemon creates and manages Docker objects, such as images, containers, networks, and volumes. Docker terminology. Docker images and Docker containers are the two essential things that you will come across daily while working with Docker. In simple terms, a Docker image is a template that contains the application, and all the dependencies required to run that application on Docker. On the other hand, as stated earlier, a Docker container is a logical entity. In more precise terms, it is a running instance of the Docker image. What is Docker Hub? Docker Hub is the official online repository where you could find all the Docker images that are available for us to use. Docker Hub also allows us to store and distribute our custom images as well if we wish to do so. We could also make them either public or private, based on our requirements. The advantages and disadvantages of using Docker. Advantages of using Docker. Some of the key benefits of using Docker are listed below. Docker supports multiple applications with different application requirements and dependencies, to be hosted together on the same host, as long as they have the same operating system requirements. Storage optimized. A large number of applications can be hosted on the same host, as containers are usually few megabytes in size and consume very little disk space. Robustness. A container does not have an operating system installed on it. Thus, it consumes very little memory in comparison to a virtual machine, which would have a complete operating system installed and running on it. This also reduces the boot-up time to just a few seconds, as compared to a couple of minutes required to boot up a virtual machine. Reduces costs. Docker is less demanding when it comes to the hardware required to run it. Disadvantages of using Docker. Applications with different operating system requirements cannot be hosted together on the same Docker host. For example, let's say we have 4 different applications, out of which 3 applications require a Linux-based operating system and the other application requires a Windows-based operating system. In such a scenario, the 3 applications that require a Linux-based operating system can be hosted on a single Docker host, whereas the application that requires a Windows-based operating system needs to be hosted on a different Docker host. Getting started with Docker command. Walkthrough of Docker Hub GUI to find the images. Click on the link https://hub.docker.com/ and sign up. After this, search for the image you need to use. See figure below. After this, first, we have to install Docker in CLI. To download the dependencies of Docker command yum install 𝐌𝐄𝐑𝐂𝐇 device mapper persistent data LVM2. After this, adding Docker repo command yum config manager add repo https://download.docker.com/linux/centos/dockerce.repo. After this, install the Docker command yum install Docker. After all these, start and enable the services of Docker using systemctl command systemctl start Docker command systemctl enable Docker to check the status of Docker systemctl status Docker. Now, go to Docker Hub and copy the image, which we want to deploy. Here we are going to deploy Tomcat command docker pull, e.g. docker pull to me. To check images in Docker, command docker images after pulling the to me image. To check containers, command docker ps. Here we can see that there is no container started. Note we can also search images in CLI itself using docker search command docker search. Now, we are going to launch one container with the image. First, if we want to test the image, if everything is fine in the image or not, command docker run it. Example docker run it docker.io to me or 29b9bd0of5c8b. Here we can see Tomcat has been started, and many parameters it has been taken like Java and many more. It is for interactive mode to validate my image, to check whether image is working fine or not. When this command is running, there will be a container. As soon as we cancel the command, the container will stop by itself. As in image, we can see there is no container running at start. As soon as we run the command, it creates a container. When we press Ctrl+C, it terminates the container as soon as it closed. Second, running the image in background command docker run dname equals app1. Here we have launched the container. In Docker PS we can see the container. To enter the container, run the following command docker execute bash note in place of app1. We can also write container ID after login. This is the location where Tomcat has been installed. When we curl here, we can see Tomcat is working fine. In above method we did not open any port, due to which it will be not accessible from outside. To check IP address of the container, see command in figure. When we elinks this IP address command elinks http://172.17.0.2:8080. If elinks does not works, install the services for elinks command yum install elinks. Tomcat is working fine. To access this from outside, in that case we bind the port with the container command docker run dp8080:8080 name equals app1. Here first 8080 is for host port, machine port. Second 8080 in container port. Here we can see ports are assigned for all IPs. After this, we can access the Tomcat from outside, see figure below. If found any issue in installation, visit https://docs.docker.com/ee/docker/e/role/number repo install and upgrade. Thank you for watching. Please like, share and subscribe to the channel and press the bell icon for more new updates.